Morning all. My topic is role of cartography in GIS. Cartography as a discipline evolved from the ancient practice of map making and its complex set of conventions and techniques. GIS was developed much more recently as a comprehensive computer application for performing a wide range of functions on a geographic data. Mapmaking was moved from the field and drawing board to the laboratory and keyboard using remotely sensed imagery, geographical position system, and computers. So was the production of maps to display patterns of interest to geographers. Standard computer software packages provided geographers with their illustrative material without any need to use pen and ink. Map. Simply we can say that maps are the two-dimensional representation of a three-dimensional surface, and maps are the primary tools by which spatial relationship and geographic data are visualized. Most maps have the following common elements. They are title. The title should be in large font and easily identifiable and should include descriptive text as to the location and purpose of the map. If the map is thematic, the theme should be included in the title. Next, scale. The scale of the map is typically indicated by a graphic bar or a representative fraction or a verbal scale. The reader must be able to determine the relationship between a unit of measure on the map and a unit of measure in the real world. Orientation. A map should indicate which way is north, which means the direction. Commonly, this is done by a north arrow or compass rose. And border or neat line. A map border identifies exactly where the mapped area stops and should be close to the edges of the mapped area. The distance between the map and its border should be the same on all sides. In addition, there is sometimes a thin additional line just outside of a border. It is called neat line. And legend. It is required if the map uses symbols or colors. Maps do not need legends if the symbology is common or symbol has to be easily understood by the reader. The legend does not need to be labeled legend. Map credits include source of data, name of the cartographer, date of the map creation or publication, date of the map data, projection of the map, etc. A locator map or inset map. An inset map is needed if the area of the map is not easily recognizable or is of larger scale. And effective graphical design. The layout design is an important as effective sentence structure is to return text. The map and map elements should be neat and clear, appropriately and consistently generalized, symmetrically balanced without unnecessary clutter. And visual hierarchy. A hierarchy of symbology should be used for the lettering, lines, weights, and shading. More important features are typically larger and darker, and less important or background information should be smaller and lighter. And purpose. All maps have purpose which influences every element of the map and the map layout. A cartographer should be able to clearly articulate the purpose of their map and should keep the audience and the client in mind. And the qualities of a good map include it should be precise and easy to understand, clear, attractive, and proper structure and symbology, should have neat line and smooth edges, and must have clear and precise title and symmetrically balanced ആയിരിക്കണം, which means ലെറ്റേഴ്സിൻ്റെയും വേർഡ്സിൻ്റെയും ക്രൗഡിങ് ഒന്നും പാടില്ല. പിന്നെ ബ്ലാങ്ക് ഏരിയാസ് ഒന്നും പാടില്ല. ആൻഡ് വിത്തൗട്ട് അൺനെസസറി ക്ലറ്റർ ആയിരിക്കണം. ഇതൊക്കെയാണ് ഒരു ഗുഡ് മാപ്പിൻ്റെ ക്വാളിറ്റീസ്. ആൻഡ് ഇത് മാപ്പിനൊരു എക്സാമ്പിളാണ്. ആൻഡ് ഇറ്റ് ഇൻക്ലൂഡ് ടൈറ്റിൽ, ഡയറക്ഷൻ, നീറ്റ് ലൈൻ, സ്കെയിൽ, ലെജൻഡ് ആൻഡ് ഓൾ ദ എലമെൻറ്റ്സ് ഓഫ് ദ മാപ്പ്. Map generalization. Generalization is the process of reducing the information content of maps due to scale change, map purpose, intended audience, or technical constraints. And generalization is also defined as to fit portrayal of selected features to the map scale and to the requirement of effective communication. And generalization is the reduction of detail or simplification of reality. Reduction of the complexity of map to ensure its fitness for use. Is an umbrella term for several processes, all intended to remove unnecessary detail. Because maps cannot show everything, mapmaker must select which features to show and which to omit. Features need to be simplified to be legible at smaller scale. Data needed to be classified, divided into smaller group of similar values. Finally, symbol must be chosen to represent features on the map. Purpose of generalization. The reduction in scope, amount, type, and cartographic portrayal of mapped or encoded data, and maintenance of geographical clarity at the target scale. And basic principle of map generalization is to emphasize salient objects and omit less important ones, ensure readability, and preserve geographical meaning of the map as faithfully as possible. And generalization concepts include classification, simplification, exaggeration, symbolization, and induction. Classification means the order, scale, and group features by their attributes. ഒരു പർട്ടിക്കുലർ തീമിൻ്റെ അല്ലെങ്കിൽ ഒരു പർട്ടിക്കുലർ ക്രൈറ്റീരിയയുടെ ബേസിൽ ഒരു ഗ്രൂപ്പായിട്ട് ക്ലാസിഫൈ ചെയ്യുന്നതിനെയാണ് ക്ലാസിഫിക്കേഷൻ എന്ന് പറയുന്നത്. സിംപ്ലിഫിക്കേഷൻ മീൻസ് determine important characteristics of features, attributes, and eliminate unwanted detail. And exaggeration, which mean enhance or emphasize important characteristics of the attributes. Symbolization is the use graphic marks to encode information for visualization and place them to a map. Induction means making inferences from interrelationship among features on a map. And typification. Typify is one of the type of cartographic generalization operation in which a large, often cluttered set of similar features is placed with a smaller set of those features. It helps to create a simple and smooth view of the data represented on the map. Typification here reduces the density of the object. And first picture shows the representation of illustrating typification by classification of point, line, and area. And the second picture here is an example of typification in use. And in this display of lightning strikes along a hypothetical ocean shore, and the typification tool reduces the clustered array of lightning symbology and replaces it with fewer symbols. And map compilation. Compilation consists in transferring the cartographic data from the source material to a prepared base in order to make a compilation original. Maps may be compiled from other maps, usually of larger scale, or may be produced from original surveys and photogrammetric compilations. The former sometimes referred to as derived maps and may include information from various sources in addition to the maps from which they are drawn. Most of the small-scale series such as the International Map of the World and World Aeronautical Chart and compiled from existing information through new data are occasionally produced to strengthen areas for which little or doubtful information exists. Road map produced by the millions are compiled from road surveys, topographic maps, and aerial maps. City maps often represent original surveys made principally to control engineering plans and construction. And the type of map. The three major type of representations are point, lines, and polygons. Point means it has individual XY locations, and it is used for representing center point of plot locations and tower locations and sampling locations, etc. uh, and lines, it is composed of many vertices, at least two vertices or points that are interconnected, which is used to represent roads and streams. And polygons means three or more vertices that are connected and close. It is used for representing building boundaries and lakes. And dot map scatter dots in an area based on value. More dots means higher value. Dot maps don't necessarily show the exact location. They randomly spread out points in a given area, best for showing density differences across regions. And point maps are straightforward, especially for displaying data with a wide distribution of geographic information. For example, some companies have a wide range of business. If the company wants to view the data of each site in a certain area, it will be more complicated to implement with general maps and the accuracy is not high. Then you can use the point map for precise and fast positioning. Use scenarios includes distribution of point event. Point maps can also realize special recognition of big events like the accident tracking map above. It can identify relatively serious events with picture, text, or dynamic effect. And regional map. A regional map is also called a filling map. It can be displayed by country, province, city, district, or even some customized maps. We can know data size through the shades of color or different colors on the map, and it can be used for distribution of some features in different regions. It can realize the step-by-step drilling from the province to the city, and it can use different colors or labels for different characteristics. And flow maps. Flow maps are often used to visualize origin destination flow data. The origin and destination can be points or surfaces. The interaction data between the origin and the destination is usually expressed by a line that connects the geometric center of gravity of the space unit. The width or color of the line indicate the flow direction, and the value between the origin and destination. Each spatial location can be either a origin or a destination, and it is used for inter-regional trade, traffic flow, population migration, and shopping consumption behavior, communication information flow, aviation routes, etc. And time-space distribution map. Such maps visualize the trajectory distribution with temporal and spatial information. They can record time and spatial distribution of each point, and it is used in GPS geographic tracking and choropleth map. Maps varies the shading of each area based on its value. It's one of the most common map type because they are easy to understand and add a bit of color. They are different from heat map because they require a geographic boundary. Heat maps. Heat maps color code. These maps are color code using the density of points. For example, if there is a high density of crimes in an area, it shades the area as red, but less crimes are assigned a blue shading. By using this type of map, you can pinpoint the safest and most dangerous places in a country, and they are not tied to a boundary like choropleth maps and topographic maps. These maps are the all-purpose maps. Generally, they include terrain, natural, and man-made features. From topographic surveys, we construct this map type. Fast forward today, they still hold uh, tremendous value in infrastructure, military, and resource planning. Isoline or contour maps. Contour maps have lines with constant values joining points of equal elevation. If contour lines are closely spaced together, the terrain is steep, but if they are widely spaced apart, it's a gradual incline. On surface maps, surface maps take a set of known values and create a surface predicting the unknown ones in between. The 3D surface is common for rainfall, temperature, and elevation. And they differ from choropleth maps because they are not tied to geographic boundary or region. Network flow. Network flow maps show movement along an established network. For example, flight paths, transportation networks, and communication systems use network flow maps. The purpose is to display traffic in the map. For instance, the thick lines have denser flow, but thin lines have less traffic. And word map or typography. Word map assign dominant keywords to features, filling in the area of the map. Word placement is key for this type of map in terms of rotation, scaling, and skewing. Large words suggest an influential topic, whereas small words puts less emphasis on keyboard. Conclusion. Modern cartography largely involves the use of aerial and increasingly satellite photographs as base for any desired map or chart. The digital transition implicit in the development of GIS had profound effects also on the nature of cartography. Both cartography and GIS have developed and published strongly overlapping research agendas in recent years, and a comparison makes interesting reading for both the similarities and the differences. Both fields are concerned about uncertainty and how to convey what is known about to the user, and both fields are concerned about the rapidity of technological change and the abilities of researchers and developers to exploit innovation. And these are my references, and thank you all.